Okay, good. I'm going to quickly run through really quick. So I have quite a lot of moving pieces to this to this demo. I'm going to run through a little bit of context around what LSDautomate is and how the likes of GitLab and Ansible Tower fit in and integrates. And we're going to be showing some of that pattern, amongst other things. But at a very high level, LSDautomate is integrated Kubernetes DevOps awesomeness. It's an ecosystem of tooling that we build, support, maintain, and integrate. That's really supposed to, accelerate SDLC automation and more than anything, make the developer experience as smooth and as pleasant as possible. We endeavor to just kind of make sure that the machinery underneath, your IDE, once the commit has gone off to GitLab, in our case, things run smoothly, and in the event of any issues, of course, LSD is available to dive in and support and look into things. Another, I think, kind of key piece to LSDautomate is that it's deployed Kubernetes native. So every single tool within the LSDautomate ecosystem deploys as a container running in Kubernetes. Obviously, some benefit there in terms of scaling and self-healing, etc. But I think the key benefit really is that it's agnostic of where it runs. So you can run in your data center, you can run your preferred hyperscaler, and of course, that also means a lot of portability. Everyone's kind of concerned around things like cloud lock-in. Just to kind of run through at a very high level, so you're going to be seeing, I guess, 2 of the 6 today, and some of the integration between GitLab and Tower, but we're also kind of delving quite heavily into the GitOps side of things, some Kubernetes CI, and then I think the thing we're most excited about is Ahoy, which is our own in-house developed Kubernetes native release management tool for specifically around microservices and reasoning around versioning of microservices and the services within them, which is kind of why it was built out. So before we kick off the demo, just a little bit of context as to what you're going to see. We're going to start out in GitLab. We're going to build a microservice as part of a kind of greater suite of services. All our builds run in Kubernetes using the Kubernetes executor, so the Kubernetes runner. When we create a merge request in this instance, it's going to result in the creation of a review environment. So GitLab has this notion of review environments, as Aaron was alluding to earlier, and that's where you can kind of UAT, QA, or do any kind of functional test automation that you might want. We're going to actually kick off a performance test against our review environment of the service that we pick on, and then once we are complete with our review and the merge is approved, we will collapse that review environment completely. So the review environment is really going to be a separate namespace that gets created, an ephemeral place where our new build artifact can be tested. On the Ansible Tower side, Ansible Tower in this instance is pretty much facilitating and orchestrating all of the deployment activities as well as the undeployment as such. So creation of review environment, removal of review environment, deployments of new artifacts to our dev, staging, and production based on certain rules that we've got in place. Towards this end, we're actually using a container instance. So we've integrated Ansible Tower with our demo Kubernetes environments, and it actually spins up a pod when we execute Ansible jobs. And we're actually using a custom Ansible runner base image that's pre-installed all of the different modules that we need for things like Kubernetes and various other dependencies that Ansible has to talk to and integrate natively with things like Kubernetes. So it kind of really reduces the time to live to get up and running quickly. And then, of course, we're also leveraging Tower for the things that are, it's very good at, such as making sure environments are managed. We've got inventory represented, inventory management, different job templates with scope tokens, for example, and then using Ansible Vault for protecting credentials. Okay, cool. So that's kind of the context. I'm going to kick things off with just a bit of an overview as to some of the pieces, and I'm going to run this fairly quickly, just so we can also give some time towards the end there. So what you're looking at is our demo GitLab environments, and you're looking at a subsection of the LSDautomate scaffold. So we, have these customized base images. A lot of customers generally will run into issues. They go down the line of, incorporating container native CI/CD. with their own CA certs, their own proxies. So we're able to pre-instrument all of those with our own custom-based images, and then of course update them and ensure that they are maintained. We also have a number of scaffolds. The scaffolds are effectively inclusions that we can wrap in with, for certain types of builds or deployments, and that's a growing ecosystem as well. So you will see some of the scaffolds for inclusion as part of the demo. So the service I'm going to pick on for this demo is our LSD widget service, which consists of 3 microservices, really: a pricing, supplier, and product. These are all fast API little Python apps, just kind of illustrative. And the one that I think we're going to pick on for our purposes is the product service. I'm just going to quickly give a bit of an overview on how Ansible Tower is set up. So I'm just going to clock in here. So I just need to refresh. So what we've got, it's slowly refreshing Ansible Tower. There we go. So we've got a number of job templates, which are used to both deploy and remove our microservices to our demo Kubernetes environment. And just to kind of recap on what the container instance group looks like. So in a very similar way to GitLab runners, where your builds run, your CI jobs run as containers, in our case it's pods in Kubernetes, you can leverage container groups to achieve much the same pattern within Ansible Tower. And we actually use GitLab CI to build us a custom base image that Ansible Tower will use when invoking a job template. Job template execution actually occurs as part of our GitLab CI pipelines. So we've got GitLab CI jobs calling out to specific Ansible job templates. So it's quite a nice pattern where we have this almost ephemeral, sort of like a Lambda for CI, where we run a build, a pod gets created, it invokes deployments, Ansible Tower invokes a pod, and of course everything is spun down once those jobs are completed. Alrighty, let's kind of go into the demo itself. So this is my LSD widgets product service. It's just a fairly simple fast API application. I like to create these widgets because I get to come up with ridiculous product names. That's really why I do this. So what we're going to run through is a merge request, which will invoke a new pipeline, an attached pipeline that's only going to run for the merge request. And essentially, that's a way to validate that the code going into a long-living branch is sound, is buildable, the tests run, etc. Part of that merge request, we've got the option to kick off a performance test, which we'll run just to illustrate that, how you can achieve these patterns. Behind it all, Ansible Tower, being called by GitLab, will create us a review environment. And that review environment will have its own namespace with the code checked out of our merge request branch. Now, a few of the things that I do want to quickly show off before we get into the nuts and bolts is we've got consistent pipelines that are that we're used to build across all our microservices in this instance. And we've got a developer named Bob who's just built a feature to update our base image. And that's linked to an issue. So issues are obviously ways of making sure you're kind of tracking things as a developer. And one of the nice things with using the integrated issue check in GitLab is you can link MRs and commits to your issues. So you can have a nice, easy way of commuting issues through their life cycle and ultimately closing them on a successful merge or build, for example. Quickly run through what the pipeline looks like, and a bit confusing because we are using some of the security primitives inside of GitLab to do static analysis, container scanning, and so you see quite a lot of, let's say, superfluous stages here. And this is through template inclusions. A high-level view of what that looks like. This is our GitLab CI pipeline. We're including some of our own scaffolds just to aid simple, container builds as well as simple container deploys via Ansible Tower. So that's all built out as a scaffold. We've got some workflow rules which define when pipelines should be executed under what's, kind of situations or contexts. And for us, we build if there's a merge or a merge request, if there's a commit to a branch, or if there's a tag that's been created, that comports to semantic versioning with a V in front of it. So we kind of use that fairly consistently. What we've done in the past for customers, LSDautomate customers, is this is all very adaptable, and not every team wants to be dictated to in terms of how they do branching and how they want to run builds. So I guess what I'm trying to imply is that a lot of this is obviously subject to change and quite adaptable and modifiable. We're still able to leverage some of the acceleration we get from the scaffold. So we're just running our builds. We're running a simple single unit test, and then we're going to do a container build using our container scaffold and a deploy using our Ansible Tower deploy scaffold. So fairly straightforward there. I am going to be driving some of this from the console just purely because there's quite a lot that'll happen in short order. And so I guess the first thing just to validate is we've got 3 namespaces that are housing our LSD widgets, microservices at dev, stage, and prod. And if we just have a look at any of them, we should see what those 3 services running: pricing, product, and supplier. When we kick off our performance tests, we're going to see lots of new products being created, prices being created, suppliers being added. And what this actually will do is it'll invoke the performance test against the review app that's being built, but include the staging environment because we want to actually test that everything runs and is sound from a staging perspective onwards. So that's the aim of this demo. And the other thing we'll see is a review environment being created. So I showed you the 3 namespaces running out different tiers. We'll have a temporary review environment that upon successful completion of a merge will actually be removed. And quite a nice pattern and a nice easy way to run your testing without consuming static resources permanently. So I'm going to be wearing 2 hats. The one hat that I'm putting on now is Bob, because we've applied some rules that prevents the same developer, for example, from approving their own merge request. We've also put in some synthetic rules around what's permitted from a vulnerability scanning perspective. That's not going to run. Our feature branch is just completed. From a feature branch perspective, we're only going to do the bare minimum necessary to prove that our build passes, which it did, and that our tests run. And these are some of the built-in, very easy to get up and running with GitLab, security primitives for static analysis and dependency scanning. And of course, as Adrian alluded to, we can actually go and introspect any of the security vulnerabilities found within our this repository, from a container vulnerability perspective down to a dependency scanning perspective. So are we installing Python dependencies with known vulnerabilities? And synthetically, that's what we're going to remediate now. And most of these high ones are coming off the container security side. So I'm going to open this merge request as Bob. I've assigned it to myself, and I've given it some labels. And I've told GitLab to delete the source branch, so delete this feature branch where we're updating our base image, which includes a new AR HTTP client. Sorry, I just want to actually switch this around to the developer branch, so I'll just call it that now. Cool. We can't actually merge directly into the main branch. I'm going to assign it to myself, and I'm going to ask myself as other Julian to approve it, and I'm just going to say that's a work in progress label. Cool. Now, what that's going to do is actually create a slurry of notifications to me, both as Bob and as Julian. And this is going to kick off a GitLab pipeline on the back, in the background. It will be a detached pipeline, which means that because it's running off of a merge request, you'll see there's a separate kind of temporary or ephemeral branch that gets created that's going to run through our stages. Just to show you, I'm a big fan of having asynchronous comms, so we can see a whole bunch of notifications coming through saying that there's a merge request that's been opened. You might want to go and look at it and approve it. And of course, I could quickly go and click, and it would take me directly to the merge request where I could merge it. If we kind of just have a look-see at what's happening here, we're running our test stages, and then we're going to build a specific type of container. So our container scaffold builds us an OCI compliant image, and this will be a kind of temporary image only used as part of our review environment deploy. Once we get to the deploy stage, we'll see a job being fired off from one of our job templates. We've got 3 job templates pre-set up, and the product service deployment will be invoked. So we can actually just wait for GitLab to call out to Ansible. I think one of the neater things with this pattern is we're actually passing a whole bunch of job-specific metadata through to Ansible Tower at deployment time. And this is to be able to apply annotations to our various resources, denoting things like the commit shard, the committer, and some of the things that Ansible or that GitLab actually needs to be able to reference a environment once a pod has been deployed. So this is going to be building our container image. We use Kaneko, nice and headless and super simple to reason about. No need to have any kind of Docker socket. And this job will now be invoking our deployment via Ansible Tower. We actually use our Tower client base image, which has a specific OAuth token that's allowed to execute our deployment job. So I'm just going to close that. And we should see a new job being invoked. So this is our Tower client calling out to Tower and saying, hey, we've got a deployment running. And if we go and do a little bit of inspection on the job itself, we'll see that there's a whole bunch of things that are relevant to this specific deployment. We've also got Tower itself telling us, hey, a deployment has just been kicked off. So be aware. If we just have a look at what's happening in our namespace, you can actually see that Ansible Tower has invoked a pod in which this entire playbook is being executed. So it's got all of the tooling and dependencies necessary to run the whole deployment playbook, which is using the core Kubernetes module to talk to Kubernetes and talk to our cluster. We actually get a little bit of output directly from Tower telling us what's happening. And we can see that a deployment has just been completed. It took 47 seconds. If we jump over to Tower, we should see that's much the same. It's reflected as completed here. The logs are quite involved, so we need to go through all of them. So that's great. We've got a new environment now that's been deployed. Because this is a merge request, it's created this independent review environment. And if we go and have a look at the namespaces, as I was showing before, we've now got a temporary and separate namespace, which has the actual merge request ID in its name. So this is a temporary namespace. And we can actually just have a look-see at what's been deployed there. We should see our product service, so our latest and greatest. And if we were to just have a quick introspection on the product service, we'll see that it's been annotated as part of the Tower deployment with all the relevant details. So if we ever wanted to, track back to the commit that actually built this container image with this version of the product service in, we could actually just go to GitLab, look at commit history, find our SHA, and then we can actually go and do whatever kind of introspection we need. And of course, we're deploying this as a kind of temporary image that will be removed. So now we're in a position where we've got a build, but as part of our standard, we need to kick off the performance testing before we're able to continue and complete the merge. So Bob, as the ever-patient developer, is waiting for the ever-lazy Julian to complete this merge request. And me as Bob can't actually go and close it. It's now at the behest of the other guy who is a maintainer to run it through its paces. And of course, this we've said is manual, but this probably would be automated in real life. You want to kind of get out of your own way and not have lots of manual slow steps. But I do want to just be able to kind of illustrate a few of these things and hence why it's on manual. What we should actually see is a review environment, and we can actually jump over to its ingress. Well, let's just go to docs, and we can actually see, okay, so this looks much the same. I've got a health endpoint, of course, and we should have pretty much nothing left here or nothing new added yet until we run performance. So what I'm going to do is I'm going to say, cool, it looks like it's up, kick off our performance stage. And if we just watch our logs now, we should, in short order, start to see a whole bunch of requests. We only run code for 10 seconds because it costs money. And here we can see that our load generator is actually creating products, deleting products. If you look at our staging logs, we should see much the same. So we run review against our staging environments, and it looks like everything is computing successfully. And we should see similarly in our outputs. So about 10 seconds elapsed, not too bad. Happy to approve. Now, upon approval, what will happen is GitLab will actually call out again to Ansible Tower, and it will invoke another deployment, except it's going to remove our review environment completely. But at the same time, now we're merging it to develop, so that should invoke a new deployment to our develop namespace. So I'm going to approve this. And that will result in Bob being notified that just have a look here, that his MR has been approved, and I'm going to merge, and I'm going to remove feature branch. We don't need to have all sorts of cluttered branches happening. So if we jump back over to our pipeline, of course, getting lots of telemetry about this, we'll see that the stop stage is now being automatically executed, and we should see another job in short order coming up to both remove our review environment as well as deploy our new develop product service. We've taken our new base image into the develop stage, and of course, a subsequent MR would ultimately get this into staging, and if we tag it, we could cut a release, and we'd be running on the latest AI or HTTP client with some confidence. So just waiting for the removal to kick off. Lots of notifications, which is potentially a bad or a good thing. Yeah, we can see that this is the MR review stage, and noticeably, I mean, I could have cleaned up the notifications a bit, but simply just telling Tower, hey, set the state to absent for our LSD review namespace actually runs in the same playbook, just setting a state flag. Obviously not something you want to do without some oversight, purely because you don't want to accidentally lose something else. And we'll see that this will disappear in fairly short order, and I won't be able to execute anything. No, it's busy going down. So yeah, here we can see our environment's been removed, and GitLab should reflect the same, complete, wonderful. And the last stage is to complete a deployment of our new developed environment, which is also invoked by Ansible Tower.